Hello students, so let us learn a new topic in electromagnetic theory. We will continue our lecture, we will continue our course that we started for the dielectric materials. And in the last lecture we had learnt about the concept of polarization. So let me remind you in brief what is polarization. Polarization means when you are applying an electric field to a neutral material and it is an insulator, in that case the positive and negative charges are separated by a small amount. So after the application of electric field, what happens? There is a positively charged region and there is a negatively charged region. So there is a small separation between the positive and negative charges, and there is an electric field that acts inside this material. And an equilibrium is established between the external electric field and the internal electric field or the induced electric field. So let us understand this with the help of a simple problem. And we have taken a model of atom where we have a positively charged nucleus and a negative charge of electrons, negative electron cloud surrounding the nucleus. We have a simple model of atom. The nucleus is positively charged and same amount of negative charge cloud is surrounding the nucleus, which is the electron. And this distance is a. It is spherically symmetric. The radius of sphere is a. Radius of sphere is a. Now, on the basis of this topic that I am discussing here, many objective questions are asked. I will tell you what type of questions are asked. So this is the situation, this is the spherical distribution. Now what happens when we apply an electric field? Now when an electric field, external electric field is applied, what happens? Because you have to make the things clear that what is the neutral state and what is the charged state. Many times I have experienced that the students are confused. They are confused between the charged state and the polarized state. So this confusion should not be there. This is the neutral situation and this is the polarized situation. Now what is happening? Try to understand. It is very easy. Electric field is applied, then the electric field E exerts a force on the nucleus, which is positively charged, nucleus and the electrons. For the time being, we are not considering the massiveness of the nucleus, and we know that the nucleus is very massive. It will not move, it will not be displaced considerably compared to the electrons. I am giving this diagram here also. So if this is the direction of electric field, the positive nucleus will tend to move. I will not say move, it will tend to move in this direction, and the negatively charged electron, it will experience a force in the opposite direction because it is negatively charged. So what is happening? Due to this electric field, there is the induction or a separation is induced in the system that was initially symmetric. So there is a separation, try to understand in this way, separation which is induced. Induced means it is injected from external sources. This is the most simple definition of meaning of induction that I can provide you right now, which is induced due to E external. Now try to understand the thing very carefully. This is external field. So it is inducing a separation. The nucleus and the electron cloud, they have moved slightly in directions opposite to each other. So what is happening now? Initially the nucleus was here at the center, and it was a spherical system, spherically symmetric system. Now the nucleus has displaced, maybe by a very small amount, by some distance d from the initial center. The net effect is that the nucleus has shifted by a very small amount of, suppose it is d as depicted in the diagram. So now there is a very small distance that the nucleus has shifted, or you can say the nucleus has shifted by d, from its center. The center was that point when the atom was neutral and it was not experiencing any field. Suppose this point is O. So now the center is shifted from O to, suppose it is O dash. This is the situation that is occurring due to the application of the external electric field. This is what is happening. And I am telling you again that the shift is very small because the nucleus is very massive. Now what happens? Here again the students are confused. At the equilibrium means when the two forces are balancing each other. Forces means the electric fields in this case. They are balancing each other at the point of equilibrium. This thing is happening. At the equilibrium, the nucleus will no more shift. It has already shifted to distance d from the initial center. The distances or the shifts are very small. So you can say the spherical shape is maintained because the displacements are very small. And we are talking about intermediate fields, less fields. The point of equilibrium, the nucleus has already shifted from the initial center by a distance d. At equilibrium, this is a very important point and you should be clear regarding this. At equilibrium, the nucleus is shifted by distance d. So when equilibrium is attained, there will be no more shift in the nucleus. There will be no more shift in the charges. No further shift because it is the equilibrium state. No further shift. It is an equilibrium state. So this is the situation that is occurring at equilibrium. Now what happens further? At this point, what is happening, the external field is still trying to push the nucleus to the right direction, in the same direction because it is positively charged. Now there is an internal field which is produced that is tending to pull back the nucleus to the initial position. Now what is this internal field? This is another important question. This is another important question, another important term that should be clearly understood. Because there are so many confusions that I have personally experienced when I am asking the viva to the student. At equilibrium, because you have not switched off the electric field, at equilibrium the external field, you have not switched off the electric field source, is still trying to push the nucleus, to push the nucleus to the right. I am giving you the diagram again so that, because the screen is moving down. So this is the situation. This is the electric field, and because nucleus is positively charged, it will move in the direction of the field. Now what happens? An internal field, because this is not the this is the situation which is not required. The neutral state, there is a balance. When you have this polarization, this is at this stage polarization has occurred. So there is something that is trying to bring back the system to the natural state. An internal field tries to pull back these things. Are provided in the textbooks, and they are very simple when you are reading this, but at the time of questioning, everything is confused. So you need to understand the things very properly. Where does the internal field is coming from? Trying to pull back the nucleus towards left, because it is trying to set or trying to create the initial situation that was in the neutral state, nucleus towards left. Now the question is, what is this field? If you are asked how to calculate this field, now what is this field? This is trying, the external field trying to move it right, the internal, there is another field that is trying to move it back. This field is due to the charge cloud, electron cloud, or the negative charge that is due to the electrons. Now at a distance d from the center of a uniformly charged sphere, because try to understand the things properly. Initially this was the center, and now the distance has shifted by a amount of d. So what will be the field at this point? And you can calculate this thing, because you have studied electrostatics, and if you are not able, we will see how to calculate this in some other lecture. The electric field, because this sphere is charged, electric field due to the charged sphere at a distance d, you can calculate this from Gauss law and other. You must have solved this problem, I think. At a distance d from a uniformly charged sphere is, now this electric field, I think you know, it is proportional to 1 upon distance cube, 1 upon radius cube. It is EE, 1 upon 4 pi epsilon naught. This is due to electrons, QD by AQ. If you are not acquainted with this expression, you can tell me in the comment section. I will discuss this thing, but in a different lecture, at some other lecture. Now this is the electric field due to the uniformly charged sphere at a distance d from the center, and it is the subscript E stands for electric field produced by electron cloud. So a electron cloud that is producing a field at a distance d from a uniformly charged sphere is this electric field. Now what happens at equilibrium? At equilibrium, EE is equal to E external. These two fields, they balance each other. So the atom is polarized. If D is 0, there will be no polarization. D is 0 means no polarization. No electric field will be produced. No polarization. You can check this expression. If D is 0, the shift from the center, remember this is the shift from the center. Shift from center. If this D is 0, there will be no induced electric field. This you can say the induced electric field, E induced, and there is no polarization. Because of this non-zero value of D, there is a polarization, and at equilibrium these two fields, they balance each other. So what happens at E external? You can write this expression 1 upon 4 pi epsilon naught QD upon AQ. Now you do not require to have a complete knowledge of Laplace equation and all those things. If you simply know the concept of electric dipole moment, P is equal to Q times D. A dipole is a system of two equal charges, equal in magnitude, opposite in sign, separated by a distance D. This is the dipole moment. So this one is the dipole moment. So this P is equal to QD is equal to E into 4 pi epsilon naught AQ. And this question is asked in many competitive exams as objective question, that this induced electric field, what is the induced electric field? Dependence is asked on radius, A cube, A square, A, and so on. So if you know this thing, you can at once choose the correct option, which is A cube, which is the cube of the radius of the sphere. So this is the polarization. This is the dipole. So what is polarization? Polarization means it is the dipole. It is the strength of the dipole, or it is the dipole moment which is created due to the external field. When the external field is creating a separation of charges by some small distance, a dipole is created, and the dipole moment of this dipole is this quantity E into 4 pi epsilon naught AQ. This is the external electric field. So when an electric field is applied on a material, it induces dipole moment. It induces dipole moment, and this dipole moment is given by P is equal to QD and E is equal to 4 pi epsilon naught AQ. This is the dipole moment that is created. Because the polarization means dipole moment per unit volume. Polarization, when you are defining this, it is dipole moment per unit volume. This is the definition of dipole moment, and in the last lecture we have studied P is equal to chi times E. As P is proportional to electric field, and when you remove this thing, it is E, or it is alpha, sorry, it is alpha, because chi stands for the magnetization constant. You can use chi also, in many textbooks they use chi. So it is alpha E. So from comparing these two expressions, you can write E is equal to 4 pi epsilon naught AQ. And if you are considering the volume of the atom, you can write this in terms of volume. It is 3 times epsilon naught V. This is the atomic volume. Atomic volume. This is the polarization. This is the definition of polarization. On the basis of this, we can describe the molecular phenomena also. So this is what I have told you. This is atomic polarization. Atomic polarization. When we are considering the molecules, the situation is a bit different. And there is a directional dependence of this polarization on the molecular materials. So in the next lecture, we will see how this polarization is described in the molecules, and we will see a very interesting application of this polarization in daily life. So till then, please stay tuned, watch the videos, like, share and subscribe. And if you have any queries, any problems, you can tell me in the comment section.